Okay, the first trend that we're going to talk about is atomic radius. We're going to do 3 trends in this video, and then I'm going to cut them and make them shorter videos for you. But be sure to pause along the way so you can get your notes down. Atomic radius, we know a radius is from the center to the outside of the circle, and for an atom that would be from the nucleus to the valence electrons. It tells us the size of the atom. The general trend is that it increases towards francium, but we need to know why. As we go down the group, I'm going to start with going down. As we go down the group, we add more energy levels. So you can see going down, there's more and more rings to hold those electrons, more and more shells, we would call them. So going down, it very clearly gets bigger because there are more shells. But going left to right, we would be adding electrons onto the same shell. So we would expect that they would all be the same size. That's not what we see. What we see is as we add more protons to the inside and more electrons, there's more attraction. More positive and more negative can actually pull in and make that atom smaller. It's like these magnets. We have 2 magnets that are sitting at a specific distance from each other, and they're not pulling each other in. When I add another positive and negative, we take these magnets and we put them at the same, and now they attract each other. The same distance, and they now attract each other. So what we see going across is that even though they're being added to the same shell, the atomic radius actually decreases because more protons and electrons attract each other. The protons are able to pull in the valence electrons. The next trend that we have is to look at the ionic size. So in general, a cation will be smaller than what it was originally. That's because, say for example, we had this one. If we make lithium a cation, we remove this electron. That leaves only this inner shell, which is much smaller. But say we want to compare 2 cations. They both have the same number of electrons, but one has more protons than the other. The smaller one will be the one with more protons, because more protons can pull in those electrons and hold it more tightly. The anions, we see that we would think adding an electron, like for fluorine, it would be the same size because we added it to the same shell. We would think that, but that's not what we see. We actually see they get a little bit bigger because electrons repel each other. So similarly, if we wanted to compare N3- and O2-, we have same number of electrons, more protons for the oxygen, so the oxygen is actually slightly smaller. So that's the general trend for ionic size. Make sure you have that written down, so pause it and write that down. Okay, we have shielding effect is the third one that we're going to do on this video. When we think of the word shielding, we think blocking something from happening, like a shield blocks the sword from hurting the soldier. Now, in atoms, what that means is actually that the inner electrons shields the pull from the nucleus. The nucleus can't have as much of a pull on the electrons that are further away from it. An example would be like, if you're at a concert or something and you're in the very, very back row, it's a very different experience than the people who are in the very, very front row. There's a lot of shielding going on that affects the impact of the performance because you're so much further back. So in an atom, as we go from left to right, there is no change in the shielding. That's because there are the same number of electrons on the inside for every single one going across. No change on the shielding left to right. But going top to bottom, we add more and more and more shells, so we get more and more and more blocking. The outermost electron is much easier to remove from a bigger atom as we go down the group than it would be from the first one. Okay, so I like to think of the atom as being like a person who puts on more and more coats. They just keep getting bigger and bigger and bigger. So that's shielding effect. Make sure you write that down, and we'll do the other trends in another video.